In this video, we are going to be looking at amines. So firstly, we're going to look at what they are, then how to classify them, how to name them, and then we're going to look at some of the reactions that they undergo. Okay, so first things first, let's have a look at what we mean by an amine. So an amine is something that is derived from ammonia. Okay, ammonia being this compound here, NH3. It is where one or more of the hydrogens are replaced with an alkyl group or an aromatic group as well. Okay, if it's replaced with an aromatic group, it becomes an aromatic amine. Okay, if it's replaced with an alkyl chain, so by that I mean like methyl, propyl, and so on, they are aliphatic amines. Okay, we have looked at examples of aromatic amines before. The one that we've done is this compound here, which is phenylamine. So phenylamine is an example of an aromatic amine where the nitrogen in the amine is bonded directly to a benzene ring. Okay, right, moving on. So we're now going to look at classifying amines. And if you remember, when we classify compounds, like we've done with alcohols, carbocations and so on, what we've done is we've classified them under primary, secondary and tertiary. Okay, so we're going to do the same with amines. So first of all, we're going to start off with a primary amine. Now, a primary amine is where only one hydrogen in that ammonia has been replaced with an alkyl chain or an aromatic ring. Okay, I'm just using an R, a capital R, to notate any carbon chain. Okay, that could be absolutely anything, and you've still got two hydrogens bonded to the nitrogen, and that makes this a primary amine. Now, as you can see, every time I draw amines out, I put the lone pair on the nitrogen. That's very important that you do that too. So start getting the habit of it, because that's responsible for the reactions it's going to undergo later. Okay, right, so that's a primary amine. Next one is obviously therefore going to be a secondary amine, and this is where two of the hydrogens in ammonia are replaced with R groups. They can be the same R group, they can be different, it doesn't matter. And that's our secondary amine. You still got one hydrogen bonded to the nitrogen. And last but not least, we have our tertiary amine, and this one is where all the hydrogens in ammonia have been replaced with R groups. And again, they can be the same, they can be different, it doesn't matter. Okay, so that's how you classify an amine. Let's now have a look at how you might name an amine. We're going to start off with our primary amines first. I'm going to start off with the simplest one, I would say. It's where you have the R group being methyl. In this case, the parent is the amine. Okay, so the name is going to end in amine, and because you've got a methyl group here, this compound is simply methylamine. That's one word. Okay, moving on, so let's just extend the chain. So we've got our ammonia, our amine group at the end of this 3-carbon chain. In this one, again, the parent is amine because it's found on carbon number 1, and it is a primary amine. And in this case, this part here is just the alkyl chain. It's 3 carbons, so this is just simply propylamine. Okay, now the bit where it changes slightly with primary amines is where this amine group is not found on carbon number 1. So all I'm going to do is I'm just going to swap over this amine and this hydrogen here, and we'll see how the name changes. Okay, so it's still a primary amine, nitrogen still bonded to 2 hydrogens, but now this amine group is not at the beginning of a chain, it's in the middle, so this actually makes it a substituent. Okay, the longest carbon chain is the parent now, so it's propane. And now so in terms of numbering it, 1, 2, 3, the amine group is found on carbon number 2, so it's going to be 2, and then amine as a substituent is called amino, so this is 2-amino propane, like so. Okay, let's just do one example. I'm going to just kind of extend the chain and see how to name that. Okay, so again, it's still a primary amine, but now the amine isn't on carbon number 1. So the longest carbon chain is our parent. So this is a 6-carbon chain, so it's going to end in hexane. The amine group is found on carbon number 3, so this is called 3-amino hexane, like so. Okay, that's a 5, sorry. Like that. Okay, right, let's now move on to secondary amines. And a secondary amine is where 2 of the hydrogens have been replaced with an alkyl group. So let's have a look when those R groups are the same, like that. In this case, the parent is the amine, so sorry, different color pen. The parent is the amine, it's going to end in amine. Okay, because you've got 2, so this part here is the parent technically, because you've got 2 methyl groups, it's going to be dimethylamine, like so. Okay, so this is dimethylamine. If we've got 2 ethyl groups, so if I just substitute those with ethyl groups, so C2H5, like that, this will therefore become diethylamine, like so. Okay, the tricky part is where the R groups are not the same, so let's have a look at an example of that. So I'm going to have 1 methyl and 1 ethyl, the same thing, 1 ethyl and 1 methyl group, like that. Okay, so now you've got to decide which one is going to be part of the parent. You always go with the longest carbon chain. So in this case, the ethyl is the longest out of these 2. So the name is going to end in ethylamine, like that. Okay, and now because the methyl group is coming off the nitrogen, it's a branch off the nitrogen, you have to say it's coming off of the nitrogen, so you write N-methyl ethylamine, like that. Okay, so this part here, the ethyl becomes part of the parent, and then the N-methyl is the branch coming off of the nitrogen. Let's do a tertiary amine, and I'm going to go for something simple to start off with. I'm just going to put all groups to be the same, so they're all ethyl groups, like that. Okay, so this one should be fairly straightforward. It is just triethylamine, like so. Okay, the tricky part is where all 3 groups are different, so I'm just going to cover that as well. So I'm going to have 1 methyl, 1 ethyl, and 1 propyl as well. That's a 7, sorry. Okay, so now parent is going to be the one that's part of the parent is going to be the longest, so that's going to be our propyl. So we're going to have propylamine at the end, Okay, and then we've got two branches coming off the nitrogen. We've got methyl and we've got ethyl. You decide the order of these alphabetically. Ethyl is first, so it's going to be N ethyl, N methyl propylamine, like so. Okay, right, let's move on to the reactions that they undergo. And the reactions that they undergo, as I said, are based on that lone pair of electrons on the nitrogen. So let's just do one example. I'm just going to go for methylamine, like that. Okay, now because of that lone pair of electrons, this can accept a proton. So amines are bases. So this is an example of a base because it will accept a proton. Okay, so we can do this reaction where it accepts a proton and it is going to form an ion like this one over here with a positive charge, which we show with square brackets and the charge outside. Okay, so this lone pair of electrons have been donated. Both of them have been donated to form a dative covalent bond with the hydrogen. Remember, we can show a dative covalent bond with an arrow. You don't have to draw that in, but that's what is happening there. Okay, so this over here is called methylamine. And this over here is called a methyl ammonium ion, like that. Okay, so amines can act as proton acceptors because they are bases. They have a lone pair of electrons to donate. Okay, right, because they are bases, that means they can react with acids to form salts. Okay, so I'm just going to do that generic kind of equation here. So amines can react with acids to form salts. So I should have done amine plus acid, singular. Okay, so amine plus acid forms a salt. Okay, let's now do an example of that. The amine that I'm going to choose, I'm just going to stick with methyl amine. Okay, so CH3NH2, that's methylamine, reacting with an acid, so I'm going to react that with HCl. That's going to form a salt, because remember the lone pair of electrons is going to accept the proton from that, and that's going to form CH3NH3+. Okay, it's going to form methyl ammonium. But remember, we've still got that chloride ion hanging around as well. Okay, so that's going to come over here and form a salt. So it's going to form this salt over here. If that was methylamine, if that's methyl ammonium, that's chloride. This over here is called methyl ammonium chloride, and that's the name of our salt. Okay, I'm going to do one more example of that with sulfuric acid because the charges are different now, so it'd be nice to get that example in as well. I'm going to stick with that, but I'm going to change the acid to sulfuric acid. Okay, the reason being is when we form CH3NH3+, okay, we also have SO4 2- because the sulfate ion is SO4 2-, and as you can see, the charges here don't balance out. Okay, and that's why you need two lots of this whole thing to balance with that. Okay, and as you can see, in order to balance this equation, I then need to have a 2 in front of here as well. Okay, so be careful with the charges of your ions. So for example, if you want to do the one that we had before was that, you can have it like that without the charges, or you put the charges in, you put both of them in. Okay, same with that one here. You can put the charges in like I've done, or you can do it without the charges like that. That they are both correct. Okay, so just be careful with your charges for those.